picture, not like all, but just.
Okay, so here we go. Next class, you'll see your assignment is, you'll have a quiz on integration, like where we are right now. So it could have, partial fractions, integration by parts, substitution, different techniques. I'll obviously give you a link or problems to study. And what was the other assignment I had in mind? There was like a two-part. Oh, and also let's all get this out so you know what I'm talking about, and make sure everybody has one. I've tried over this period of time to make sure everybody has this packet. I may provide this to you. It's a big packet called Integration Practice, but I'm gonna have to look at it again and make sure I like it. If not that, you'll get like a life binder link or something. Oh, by the way, Grace is the only one that was able or was required to come to parent-teacher conferences, and we were talking with her mom about life binder and how I really like the fact that I'm not looking at life binder when I make out quizzes and tests, but I only have so much, I've got 40 or 50 years of material to draw on since AP Cal's existed since like 1969 or something. But anyway, I'm not trying not to pick things because I almost couldn't. LifeBinder was created, I don't know how recent it is. They haven't updated in the last few years that I know of, but nor do I care. Because there's such a big, volume of problems there. And if there happens to be one on a test or a quiz that you have the drive to study, then that's great with me, okay? If you go from here on out, and talking with Grace, I decided it was a really good idea to do this. From here on out, I think I've updated it. You might want to try it later, but I don't think it'd be just special to my computer. If you go to, I think it's under Study Guides, and now you have all the live binder practice. Of course, you probably want me to still guide you through things because it's hard to pick out. Why I didn't give you this at the first of the year is it would have driven you crazy to pick on derivatives and differentiation, in the months that you didn't know exponential and logarithmic. Then you have to sit around and panic and, oh my gosh, I don't know how to do this yet. But you're in a place where you may want to jump around in there on your own as you're reviewing, or you may find you need extra practice before a test that I don't give you, and so you can see all the different things that are in there. That's why, and I just have always linked you straight to the ones that you need. But there it is, okay? So that's fabulous. So, pause, back to homework for Wednesday. You'll have a quiz on integration. It could give you LifeBinder. I won't just go study LifeBinder and leave it up to you. I'll pick out some problems that I would put on the quiz, or give you a packet. But also, everybody can see if you have this, or if you have it at home, okay? And so you don't have any written homework for Wednesday. It'll be the study for the quiz. All of the questions on the quiz will be just integration, okay? All the questions on the quiz will be different integration techniques, of which I'll provide you something to study so you can focus. Obviously, if you're trying to do one integration by parts and you don't remember how to do that, then you can go back to your notes, video, and stuff like that. So it'll tell you what you need to know to walk in the door. Also, I'm going to take this and I'm going to just have strips cut out with the problems, and you'll reach I'll have them up there on the table, and you'll just draw one, and that'll also be part of your quiz, but you don't know which one you're going to draw. All right, so, but the good thing is that you can study each one of them. You don't know which one you're going to get, and also it's got all of the answers that I'd be looking for, okay? So make sure you have that packet, and I'll specify all of this on assignments. So you'll have one of these, in addition to 4 or 5 integration questions for our quiz. So you'll be studying, okay? So what I would suggest is maybe work them with it folded, and then you can unfold it and see how you did. But also having the answers right there keeps you from having to search around for the solutions like you normally have to do. So you'll have one of those, okay? And obviously there's not enough for everybody, so some people will end up with the same problem. Just depends on what you draw, okay? And please, maybe, study ahead of time, and November high school, y'all know how to get in touch with me anyway. But I would love to sit down and work as many of these problems as you need, so just let me know. Okay, so let's start with questions that you have lingering, or questions from the 2008 packet. I didn't bring my worked packet down here, which is really kind of silly. So I may ask and see if it's the right answer, because most of you have your own circle. I just have the number circled that I signed. I have a worked packet. Oh no, that's okay. I'm not even sure where it is. I think it's in a big bucket somewhere. Hopefully I know how to work these. Caroline?
I had a question for number 19. Okay. I looked at the other online. I
Yeah.
did the same A and B, but then I don't understand why the coefficient for the first term is 3 halves.
Yeah, that's what I didn't do.
Oh, okay, so it was a partial fractions one. Okay, probably a chain rule issue is what I'm guessing, but let's see what happens here. Okay, so we have the integral of 7x over 2x minus 3 times x plus 2 dx. Don't know if you thought about it, but as we head toward quizzes and tests that are ongoing, there is a chance you should have maybe pulled out the bottom and just seen if you could have done substitution here. Distributed the bottom. When it comes out you factored like that, chances are super high that you are going to be doing partial fractions, or when the bottom, just be careful. So if I had the integral, you've had some that look like this before, like 2x plus 1 over x plus 3 times x plus something else. There's a high chance substitution might work there, okay? Because I'm going to have an x squared and so on and so forth. You should always try substitution first. However, now we're entering a time where substitution and integration and partial fractions might both work on the problem. And you can pick and choose which one you want. Many times one is better than the other. Just suffice it to say, I want you to think about simplifying and substitution before you start, and I'm probably going to say it every time. Just like when I take the derivative of an exponent, even if it has base e, I'm going to write e to the u, ln e, the derivative of u, so that you remember that process. All right, so moving on, I would say a over 2x minus 3 plus b over x plus 2 is equal to 7x over 2x minus 3 x plus 2. All right, so I said a times x plus 2 and b times 2x minus 3, and so that would guarantee me a 7x. One thing that I don't know if I did an example in class, maybe by video or something, you want to put in for x all the way across. And so if x is equal to -2, which is what most people probably chose, that would give you, is that -7b equals -14. So I put -2 in for every x. And so b is 2. Then I put in x is equal to 3 halves. And so you have 7 halves a. 7 halves a equals 21 halves. Does that give you a is 3?
Yeah.
Okay. So far so good. So a is 3. All right, then go back to your setup here. A is 3. And B is 2. And let me pause for a minute and just really praise Caroline and anybody else that had a question on this problem. A couple of y'all were agreeing with her, like, thank you for asking this. And this really tells me that you're really taking your packet seriously. What most likely happened here is we jumped straight to ln without thinking about the composite function that we have 2x minus 3. Like, there's a chain rule. Now all of a sudden I'm on an old integration thing. I'm going to have a 1 over u. All right, so I'm going to, since on video you can see what's all down here, so I'm going to get rid of it. Okay, so I'm going to integrate this. And here I can't just go 1 over u. I'm going to have to think of what u is. That's why all u I've written in this simple The only thing you really integrate is 1 over u or 1 over x, that's it. If it's not that easy, you better be careful. Alright, so u is 2x minus 3, and du is 2 dx, so I get 1/2 du equals dx. Now,
Oh, okay.
if I've called u 2x minus 3 and it's a free response, if it's not a free response, you could just come over here and also try it with this one and call it like w or something, okay? However, in our heads, we can see that I don't have to do u substitution on the second one, do I? Okay, so I don't have to do u substitution on the second one. And was that the issue?
Yeah.
So it's a great thing just to flag two things. They know what our mistakes are going to be, unfortunately, and we circle it and we go on our merry way and think that we're right. Also, just I mean, cannot emphasize substitution enough. I can't. So always think about it, and when you're doing the chain rule, don't forget it. Okay. All right. So I'm going to go in and finish it. I've gone this far. I'm going to factor out the 3, and I have the integral of 1 over u, and dx is 1/2 du, and then I guess I'll just do the front one like this. Take your time on these, don't miss them. And then I have plus 2 times the integral of 1 over x plus 2 dx. Usually it just takes one.
Weird.
I know. And then when I go upstairs in 512, this doesn't happen.
I think it's like not calibrated.
Maybe. I don't know why I don't have. I still don't have extend page. What were our other ideas, or was that it? Just keep doing this until it gives it to me. I'm not gonna get it.
Try control minus
Okay.
or command minus.
Okay. So I'll go above it. Girls, you can see here that if you have limits of integration, you want to be really careful. I've got u's and x's. And so this is a case that I talked about earlier in the year that I might just wait until I'm finished and get it all back in terms of x before I put my numbers in. And don't keep the numbers trailing if you're not going to change them. Like if this was going from 2 to 5, don't write 2 to 5 on this one and 2 to 5 on that one. So just do it your way and keep checking your answers. But if you're not going to change your limits of integration, you can leave them off so that you're not writing incorrect. We call it a linkage error when we're grading AP exams. And so we have to make sure that what you're saying is mathematically correct. All right, so anyway, I have 3 halves. This one is ln u, which is 2x minus 3. And this one was plus 2 ln of x plus 2 plus c, because I don't have limits of integration. And then I don't know what our
That was your
answer.
answer, yeah.
Oh, that was it.
Yeah.
All right, if logarithms are added, you could have multiplied them. They may have like done some sort of FOIL, but first you would have to bring your 3 halves up. You couldn't like add those as they are. Okay? Great question. All right, now look at this. I can remember distinctly a year, I think it had something to do with a skydiver problem. You might see it later. You usually see all the ones I remember. So many students went in and called that ln 5 minus x. But shouldn't it be negative ln of 5 minus x? Because u is 5 minus x. Don't try to do too much in your head. You have so much you can get right. You want to get all of that right. So don't let those are where the little careless mistakes are going to creep in, and they know exactly what you're prone to do. Okay? All right, so thanks, Caroline. Other questions?
Can we do 86?
86. All right, so this is a calculator active one if it's in the 80s.
What did you say?
86. Everything past number 76,
I didn't understand this one.
we know is calculator active.
I love the blue eyeshadow.
I know, that's great. I really like blue eyeshadow.
Yeah, it was
I don't wear it anymore, but I like
It's
it.
like my 5th birthday and it's called blue eyeshadow.
Is that Cinderella? Who is that? Is that Cinderella? Snow White.
Yeah.
I knew it wasn't Cinderella. Not having the black little hair. Okay, oh yeah. The graph of y equals f of x. The slope at any point is twice the value of x. And f of 2 equals 3. What is the value of f of 3? Two things, girls. This is something that I need to make sure you hear. On calculator active problems, there's 17 of them to 15. It changes from year to year. This year I think there'll only be 15. But you'll walk out of there going, I'm going to use my calculator on 5 of them, okay? Because a lot of them are theory, and they're not even, I don't think I can use my calculator on this one unless I did some sort of investigation. So don't feel funny about that. The reason you've got your calculator on the last 15 is I'll ask you a little bit more real world applications where you've got to find maybe the sign of something you haven't memorized, or an intersection of something you can't factor. Now remember, I want you to use your calculator from the beginning. Don't try to do some algebra, because you'll either be wasting time or you'll mess up. They're not gonna have you let you have your calculator on something that you could have done algebraically. You will have already been finished with that. So use everything in its purest form. However, I can't think of anything to do on my calculator. Girls, if you're like me when you read this problem, you thought, I don't have enough, I don't even know what you're talking about, and if I did, I don't have enough information to even work your stupid problem. I mean, is that how you felt? Like, what are you even asking? So I thought, okay, I'm gonna be my students, and I'm gonna be very literal. And then I always write down as I'm reading, especially if I get confused. And so I go back and I go, the slope at any point, and I think, okay, the slope at any point is twice the value of x. And all of a sudden I had a problem to work. You see how I was very literal? I just went back and wrote down the words that they said. Are y'all okay with that? Okay. And then they want the value of f of 3, so I've got to find f. Well, all of a sudden I can find f by taking the antiderivative. F of x is 2x squared over 2 plus c. Now what? Plug in my point, find c, so I have the point 2, 3. And so I have 3 is equal to 2 squared plus c. And so is c negative 1? Alright, so I have y is equal to x squared minus 1. So I can find f of 3, I guess it's 8. Yeah. Okay, so write down what you're seeing. Because I felt the same way. I thought, ooh, what do they want me to do? They must have left something out, okay? Any other questions right now in the packet? Emma?
Can you go over 81?
Okay. 81.
I was just getting confused.
It has nothing to do probably with the problem I'm turning to. It doesn't. And again, you can't use your calculator on this one. You're just kind of, thanks for letting me have my calculator now that I can't use it. But remind each other, and I'll remind y'all to remind each other of a few things when you go into the exam that day, because I can't talk to you unless I follow you to the door of the room, which I've been known to do. Don't forget to say plus C when you integrate. And remind each other to check and make sure you're in radians for the exam, for the calculator part. Okay, so, all right, F and G are continuous, which means not a whole lot. Continuity is real important. It doesn't mean it's differentiable though. It can be continuous and non-differentiable. It's important to know, okay, we know A is less than or equal to X is less than or equal to B, and A is less than C is less than B. So C is between A and B. And you have the integral from A to B of f of x dx is equal to P. And you have the integral from C to B of the same function is Q. That's a Q. All right, and we have the integral of g of x from A to B is R, and the integral C to B of g of x is S, and I want the integral, based on all this information, I want the integral from A to C of f of x minus g of x dx. And again, it's real important that C is between A and B. So we, if we had a f of x going like this, then this would be A, this would be B, and C is in between A and B for f of x minus g of x. So I guess I'll erase this so I've got room to write since I can't extend my page because I need to look at all of this. I bet some of y'all got this. I thought that I'm going from just A to C. All right, so if I know A to B and C to B of f of x, let me write it down. I would say the integral from A to C of f of x dx plus the integral from C to B of f of x dx equals the integral from A to B of f of x dx. So if I go from A to C and then go from C to B, it takes me all the way from A to B. That makes sense? Okay. And then I have the integral over here from A to C. I don't remember how I worked this problem, that's why I'm kind of stumbling through it. G of x, and then C to B of g of x dx equals the integral from A to, oh, I'm sorry, that's not what I want. C to B. Integral of C to B, and that would take me A to B of g of x dx. Hang on just a second, Grace.
No.
Unless I wrote something wrong.
We're trying to find A to C though. So it's like
You just do that.
Yeah, you would do A
Just
to
do
B, A to B minus C to B.
I thought that it would, like, I didn't look at the first one of the problems, so I thought it was just A, B, C, but and I switched the integrals and I still got this correct answer. So I don't know like how that was. I just like,
I didn't write any of this down on my paper. I drew myself a little picture, kind of like I drew over there.
It's because we're trying
Yeah,
to,
it's
we're
just
trying to
like
find A to C.
So I only want A to C, so I have this, right?
it's A to
Because I'm trying, where's my question? Here's
You
A
don't-
to C.
You don't have
You
that.
don't
You
have
have A to B.
Oh,
and
I
B
don't
to
have that.
C to B.
easier, it would be hard.
So
Of C to B,
A to B
Yeah.
minus
of
C
A to
to
B.
Yeah, so it's
So you're
actually,
not
I'm gonna, yeah.
A
So it
to
would
B
It
minus
would be P
C to
minus.
B.
All right, so it'd be this one, which, what is A to B? R,
A to
a G of X.
Yeah.
And then C to B of G of X is S.
It would be
Negative.
plus S.
And so that's gonna give me,
P plus S.
No, it's negative.
I want A to C, so it's R minus
R minus
S. All right, so that part's R minus S.
It's easier
And then
to
the F
split
part,
into
hang on
two.
Grace, I'm gonna come back to you. I just gotta think through it myself. And then we'll look at other ideas, because I didn't work it this way the first time anyway. I mean, I did, you've gotta do something similar to this. F of X, if I want just A to C, C to B of F of X is Q. And A to B is R? No, F of X, A to B is P. So that's P minus Q?
Yeah.
P minus Q. And you have minus, so you have P minus Q minus R plus S. I don't know what the answer is.
Yeah, that's it.
That's not even what I have on my paper. I have P minus Q plus R minus S. But anyway, did I get the right answer just then?
Yeah.
Okay, good. I need to erase whatever I wrote here. What's, so P minus Q, wait. So it's B?
Yeah.
All right, so B. Okay. Good thing I didn't look at my note very much, because I've got on my paper, I felt good about P plus Q plus R. Maybe I was looking at it like they were added together instead of subtracted. I don't know what I was doing. Okay, Grace, what were you trying to say?
Oh, I just put into two integrals. So it was the integral of f of x from A to C and minus the integral of g of x from A to C. So it just made it like less complicated with all the numbers. And then I just did like the same thing we did, which was A to B minus.
Okay, if you think about it, technically I did the same thing. I looked at G separately, and I looked at F separately, and then I subtracted my answers.
Yeah, pretty much. It was just like it seemed complicated when it was there. 'Cause it was
I think it's just because I can't extend page. I'm having to go back over what I've already written. I mean, if I'd extended the page, I would have, I think, sounds like it's the same thing to me. So. Okay, sorry, that looks confusing up there, it's really not bad. The point is, I think this is really what you need to see. You can go from A to C and C to B to get the answer from A to B. Is that okay for whoever wanted 81? Okay.
Yes.
88.
Wow, it is toasty.
Okay, 88.
So it doesn't, no,
Just so aggravating. Okay.
So this is the derivative of this y. So it's the derivative of this. If the derivative is positive, then it's increasing.
Oh, that's the day I found out I got into the
Oh, that's the day you found
They
out?
sent me like a pencil that says Marymount on it. My mom was like, oh, we should send them a photo of you with the pencil. So she like made me do a whole photo shoot holding a Marymount.
Sounds like your mom. That's so sweet. This year, to let the Butler Scholars know that they were chosen, each interviewer, we made a video congratulations. That's so Except for I hate cameras, and so you had to do 85 takes, because I was so uncomfortable. Anyway, so number 88, it sounds like some of y'all were talking about it with each other. It's important that the function is positive and decreasing. That would mean that the derivative would need to be negative. Let g be the function given by g of x is equal to the integral from 2 to x of f of t dt. Girls, look, this automatically means you've got g prime. I want you to always make that connection. If you had a picture of f, you would have a picture of the derivative of g. If somebody says, hello, I integrated f and got g, that means that f must be g prime. Are y'all okay with that? It's fundamental theorem of calculus. Which of the following could be a table of values for g? Let's see. So f is positive and decreasing. It's a continuous function. If it's decreasing, doesn't its derivative have to always be negative?
F is the
yeah, but
derivative of G.
the limits, wait.
Let g be a function given by g of x from 2 to x. Oh, well, I better just be very literal. So if I want to find g of 1, so somebody said the limits make a difference. So I'm going to have the integral from 2 to 1 of f of t dt. And so if a function is decreasing and it's positive, and our table's going from 1 to 3. So the derivative's going to be negative here because it's decreasing. But if I'm going from 2 to 1,
The integral.
yeah, I don't know. What would I do here? That would give me f of 1 minus f of 2. Yeah, some
But I just
G is positive and decreasing. G of 1 minus G of 2. Okay, so if I have G of 1 minus G of 2 should be a positive if it's decreasing. But the limits of integration are switched.
That's why I create plus. And then at 2 it's 0 because that is 2.
That's
You
why
can-
it doesn't really change it.
Does it really not matter?
I just graphed it and looked at the
Yeah, same.
graph.
I thought that was the easiest.
You're like, I eliminated answers.
One thing that doesn't eliminate it, unfortunately, is G of 2 has to be 0, because you're going from, G of 2 would be from 2 to 2, but they're all 0 right
Yeah,
there.
but then you can just like think about, oh, like if it's decreasing, then like g of x should be decreasing as x like is getting positive, so that eliminates the three of them, so that leaves two options. Then you look at one, and because it's 2 to 1, it has to be negative, so it's a. That's how I do it.
Alright, say that all again, Sonia.
Okay, so basically, because
It's gotta be decreasing.
so it has to be as like x increases, g of x is supposed to like increase as well, right? Yeah. Yes.
Yeah, it's increasing.
No, it's x increases.
It's increasing.
Oh, I read it wrong, I'm sorry. F is positive and decreasing, not G.
Yeah.
Yeah.
Okay, so the slope, okay. So F is positive, so its derivative is positive, so the function has to be increasing at a decreasing
Yes.
rate. Because the derivative is positive, but the derivative's getting less and less and less, so you'd be looking at
No, the
something,
derivative is negative.
right,
F is
No, it's positive. It's
yeah,
Oh,
so.
yeah.
I'm sorry, I read it wrong, I was looking at it as function G. Alright, so F, so I don't need all this, you're right. I was thinking they were giving me information on G. Alright, F is positive
This distance is
Yeah.
and is decreasing. That means the slopes are positive, but the slopes are decreasing. So if your slopes are positive, but they're decreasing, you're looking for something that's gotta be increasing and concave down.
Yeah.
And is that what's happening with A?
Yes, A.
Okay.
I mean, like,
Because it goes to
if then you
2,
realize
and
that
then
like g of x is supposed to be like increasing as
There you
x
go.
increases, you
Yeah.
can eliminate three answers, and then you can see like what you can do.
I'm sorry, my brain started clicking in when I reread the problem, so I don't know if Selena or I have solved it for you yet. So, questions on 88. Do you understand what Selena's saying? We're saying the same thing, but I just misread it. It's another time that I want to be super literal, so this is a good problem. Hey, girls, I don't want to steal away the joy of having a calculator section, but it's usually the harder section to me. Some of my students walk out of an exam or one of my tests, they go, oh, the calculator section's easier. But you're gonna find a lot of theory in the calculator section. That's where they put a lot of theory, because you can't play around, they're not gonna give you many with numbers in it, which is kind of frustrating. I don't know why that is. But anyway, I find the non-calculator section a lot more straightforward, and which I think is a little easier. It's a lot more algebraic. Be that as it may, like which one that you want. If my function is positive and decreasing, if the derivative is positive and decreasing, I've got positive slopes, but the slopes themselves are decreasing, like 3, 2, 1. Do y'all see what I mean? Which would create something that's gotta be increasing but concave down. I think what some of y'all were trying to say as I was talking over you and thinking inside my head and trying to read the problem correctly, is you could look even at the slopes of G. The slopes would be positive, but the slopes would be decreasing on the A part. On the B part, we have the point -2, 2, 0, and 3, 3. Do you see that it's gonna pull it like that? What is it going? Up 2 over 1 and then up 3 over 1? My slopes are not decreasing. I'm sorry, I'm looking at the table like this. Let me show you what I'm looking at. This is a great problem full of theory. This is 1, 2, 3, -2, 0, 1. The slope here is up 2 over 1. The slope here is up 1 over 1. So you see the slopes are positive, but the slopes are decreasing. And like Celine said in option B, that didn't happen. The slopes were positive, but the slopes were increasing. I really love the fact of like going back to your derivative of g, which is f, is positive and decreasing, that's gotta be concave down. Different signs. Couple other things about this problem. Like I said, packed with theory. You had to even make the connection that somebody integrated f and got g, so f is the derivative of g. Also, I didn't mean to model that for you so well, but be careful that you read the question carefully, because I was not looking at the correct functions. One more thing about this though, girls, listen up, it's real important. If they see the object speeding up or slowing down, remember we talked about that, and some of you do it in physics also. You've got to look at your velocity and your acceleration. Wasn't this already starting to talk about my second derivative had to be negative? If the slopes are decreasing, your second derivative is negative because it tells you about what the thing before it is due. Okay, so I probably talked about that problem enough. Any more questions on 88? Okay. All right, any other questions on the packet? All right, Caitlin.
89.
All right, 89. Just go to the next slide. All right, 89, the function is continuous. All right, so we don't know if it's differentiable, but you know it's continuous from -2 to 2. We know that these are equal to each other, and they equal 0. So -2, 0, and 2, 0. If there is no c between -2 and 2 where your derivative is 0, which of the following statements must be true? So I know it's continuous, but it never levels off between there. Okay? So it could do something like this with a sharp corner. Oh, what's the answer on this one? E? Okay. It's E, right? Alright. I think I've already answered it, Caitlin and everybody else, by drawing that picture though. You're not guaranteed the derivative exists between, okay? And this picture, all I know, girls, don't just assume it goes like this or underneath. I think it's our first thought. It could go up and down, we don't know what it's doing. So we have no guarantee that the derivative is always positive. We have no guarantee the derivative is always negative, so process of elimination. We know that there is no f prime, the derivative could exist between there, there's no guarantee that that happens. The derivative exists, but f prime is not continuous. I just went straight to E, the derivative doesn't have to exist. Question?
I have a question. If C did exist, then would f prime of k exist?
If f, say it again?
If C did exist, then you would have f prime of k, right? F prime of k would exist.
Okay, all we know is there's no derivative at C there's no place where it's 0. The derivative of C might exist. I'm not sure what, John, what she's saying.
She's saying if there is a point where the derivative is 0, like if there is a C value that exists,
Uh-huh.
It's not.
does F
No,
prime
because
of
you
K
could
have
still
to
have
exist?
you could still have like a max, and then it could still do that thing.
Yeah.
It wouldn't have
Like you
to,
could still make a
but-
point.
You can still have another place where it doesn't exist. Just because you have one that is 0 doesn't mean, I think that's what Carla's saying.
Okay, so
Is that what you were asking?
yeah.
Okay. Great questions. Y'all are really doing this. This is great. It's very eye-opening for me. I kind of was worried that you weren't really doing this. Other questions on the packet so far? Girls, let me pause and say, please star them every time you don't understand one, okay? So that when we have a day like this, that you wondered if it would ever come, that you're ready to go. Sounds like you're ready to go. Y'all are just rattling off questions. Grace?
So for number 90, it asks if it has a table with f and g in their derivatives, and it wants you to find the derivative kind of h if h of x is equal to f of g of x. And so when I did it, I just did the f prime of g prime of 2. But
No.
yeah, so then when I looked on Mr. Gowton's,
No,
it's
wait,
all
let me
but
pause.
I was confused.
Hang on. This is a composite function. You can't take the derivative of the outside and inside in one fell swoop. So h prime of x this is the chain rule, like Sophia said. This is an f of g of x, and then you go back in and take the derivative of g of x. It's like 3x plus 4 cubed. You don't go 3 and take the derivative of the inside at one time. You bring your 3 down, leave that alone, and go back for what's on the inside. So that may have answered your question.
Yeah.
Okay? But the reason I was like, no, you've got to know your theory. If you have f of x times g of x, what that would look like, f times g prime of x plus g times f prime of x, and so on. Did that help? Okay, so that's, girls, composite functions are all about the chain. Okay, that was number 90. Other questions?
For number 83, I graphed, you're supposed to find the area enclosed by the curves, and I was finding the intersection points, but I think I found the wrong one.
All right, let me pull up the calculator. Girls, you would never find, well, here's what's interesting. She's got to find her limits of integration anyway. But if they like switch places, which I don't know if they do or not yet, you have to be really careful that you handle area correctly.
There
So
were like 3 intersections, but maybe that's a little bit weird.
that's probably what it was then. X cubed minus 8x squared, x. Okay, I'm going to start off on Zoom 6. I may change my window, but so I'm going to change my window a bit. Everybody, please listen. Usually they give us a window, and so go straight to that domain. If you don't see everything you want to in the window, don't fish around for it. You can go straight to table and find out where the thing is. I can see this one pretty good, but I'm kind of wondering to myself what it does out there. And so I think I could change my window really fast and get a good picture of it. But if not, I could go to table and say, you know, like what's going on out there at 8. Okay, well no wonder I can't see you because it's 139. But anyway, most of y'all probably just went out a little bit further. I don't think I need to go that way. All right, so I have an area. These are all such awesome questions. All right, so Caitlin, now that I've zoomed out kind of with my own management, right here, do you see I have an area here and an area here? And so, if I didn't have my calculator, I'm gonna find my intersection points, but I'm gonna have to find the intersection from A to B of blue minus red. And then I'm gonna have to say red minus blue from here to here. Does everybody see what Caitlin sees?
Yes.
Okay? Now, you cannot just do the absolute value from one point to the other point because the areas are different sizes. And so we really have to be careful to manage that one correctly. If it was over 0 and it went like this, I could do absolute value. But here I don't think I can. So let's find your intersection points before we go. All right, so I would go to second calc 5. I would go enter to find the first one. Oh, it's 1.
It's not
So
like they're all good numbers.
they're all good numbers.
Yeah.
If they weren't, I could either store them. Girls, listen, don't talk to each other for right now. In case that was a big, horrible number, some of y'all asked me about this. Watch this. If that was horrible, I would go into second quit, and I would hit X, enter, and make sure it was the number I just found, and then I can go on with my life, because I can always scroll up and grab that long number if I need it for one of my points of integration. please listen, if that's a long number, do not round it off to 3 decimal places right now, because your answer can fall further and further off the mark, because Caitlin and I have 2 integrals to do, okay? Another thing, when you're writing them on your paper, though, you can round it off to 3 decimal places, but don't do it in your calculator. All right, so that was 1. Celine, what's the next one?
The middle one is 2.
It's 2. All right, so just hang on. So I'm going to go, let's see which one's which. Right now I'm doing curve minus line. So in my y equals, I have x cubed is on the top, blue minus red. So I'm going to go math 9, and I'm going to go 1 to 2. Girls, please watch. If that was an ugly number, do you see I could go up there and grab that number, and when I hit enter, it would put it in as my limit of integration so that you're not rounding off. Then if these are really complicated functions, just make sure you're grabbing the right one. Let me look again. So I'm going to say y1 minus y2. So vars y1, darn. Let me just write it here so we can go. Caitlin, I think you've got the idea, but I would have to go from 1 to 2. Celine, what was the last one? Was it like 5? All right, so and then from 2 to 5. So this would be y1 minus y2, and this would be y2 minus y1. Girls, you already know what homework is, but just check the posting so you know exactly what to study. Let me know if you have any questions, and don't write it like that on your AP exam, okay, or on my test. Make sure you actually write out y1 and y2, or you can define them at the top, and then you can use that terminology.
I did the thing, but online it said you just do that for value.
I think if I do the absolute value,
Which
it
I
makes
didn't
me
think
worry if it's
I didn't think it was gonna work, so that's why I did 2.
You're saying from 2 to 5, they went from 2 to 5 without putting that.
Yeah, online, that's what I did. I do it two separate.
I didn't be ready on
In
it.
English, and then copies it.
Slanted, it wouldn't do that. But if you did absolute value,
I think it was an abs.
That's what I used to do.
that's
I
what.
think when she graded it.
It was
seems
like,
weird to me since it's slanted and it's got a little piece and a big piece.
I saw online that
I
they
usually
did
do absolute value, and I
yeah.
don't know why I just stumbled over that right now, because now I'm
Which
thinking.
makes
it just doesn't look like, it looks like too scary to use absolute value. But it worked out.
What would it do if you did absolute value? Oh, I guess all it would do is it would find this portion.
And it would just make it possible.
Yeah, make that
It would add them together.
Oh, okay, that's why it works, because you're doing this the whole time.
Yeah.
Yeah.
And so it would still do like backwards like that, so it would work.
Yeah.
Yeah, so you could. So
Thank you.
should have been able just to go from 2 to 5, but with absolute value.
I was nervous, so I did it with 2, but.
Yeah.
Okay, thank you, Mrs. Ayers.
Bye.